Hey guys, welcome to Practical Home Projects. So today we're going to be talking all about arc fault circuit protection. If you guys like our videos, please leave us a like and a subscribe, and put anything you want to down in that comment section down below because we'll check it out and answer any of your questions. There's several different mechanisms to protect the circuits in your house. A standard breaker already gives you overload protection, so that's if you have several devices playing at the same time and they exceed the current that the breaker is rated for, the breaker will shut it down to prevent those wires from overloading. As an added benefit, if there's a short circuit anywhere in your system, that will pull a large number of amps all at once, which will also trip the breaker. The second type of circuit protection is a ground fault circuit protection. So you can have either a special breaker that has that ground fault protection or the outlets. So you'll see these very commonly in your kitchens or bathrooms or garages or anywhere that could possibly be wet. And the way these ground fault protection work is they detect if any current is leaking out of the system, because that could indicate that there's wire in water and that could be an electrocution hazard. So that either outlet or the breaker will trip, and that should protect people from being electrocuted. The third type of electrical protection is an arc fault circuit interrupter. And what this will do is it can detect whether there is an electrical arc, which is sort of like a spark, anywhere in your electrical system. So that could be hidden behind walls, or that could be an appliance or an electrical cord that's out in the open. You can put this, once again, either in the breaker panel or in an outlet. I like to put it in the breaker panel because that will protect everything, even the wires coming right out of the panel. So since those arcs can happen anywhere, the NEC code for 2020 updated the arc fault protection requirements in section 210-12 to be most places in your residence. So it's going to be in your kitchens, your bedrooms, your hallways, your living rooms, most common living areas. Every one of your 120 volts and then 10 to 20 amp circuits are going to need to be protected. Not just outlets either, you need to protect your lights as well. So kind of the exceptions to this are, I didn't see bathrooms, garages, or anything exterior on the list. And then of course any of your double pole breakers, like if you have an electric stove or dryer, or anything that's going to be pulling more than 20 amps. Those are at this time not required as per the code. But of course, like always, check your local jurisdiction to kind of see if they have made any adjustments to the 2020 code themselves. One of the main reasons that the industry is starting to mandate arc fault protection is that every year in the United States there are about 25,000 residential electrical fires, and most of them could have been prevented from some sort of arc fault protection such as this. So there's all different ways that arc faults can happen and cause a fire. So one of the most common ones, and I think one of the reasons for this even being introduced, are electric blankets in the bedroom. So you have electrical wires that are getting mangled and they could be damaged and cause fires. You could also have wires behind the wall that get hit with a nail when you're hanging a picture or something. You could have wires in your crawl space that rats gnaw on. You could even have something as simple as a lamp cord that's just not been taken very well care of and maybe got stepped on, got damaged, and started a fire as well. Just because this new code rolled out doesn't mean that you need to go replace all of the breakers in your panel today. So if you're going to install any new circuits, then you obviously need to make sure those are up to the new code. And if you're going to be making any major adjustments, so adding new outlets or completely changing the wiring or even just extending one of your circuits any, you'll need to make sure that the new breaker is up to code. While you don't have to upgrade all of your breakers immediately, I would recommend that you upgrade them as you can, as you go along, even if you don't have any renovations coming. Because just that protection against fire is going to save you a lot in the long run. I think of it kind of like an insurance policy. Even if you have a brand new house, certain devices in your house could set off an arc fault. There are, however, a few disadvantages to going ahead and upgrading everything in your circuit panel all at once. The first one is that these arc fault circuit breakers are much more expensive than a standard circuit breaker. For example, for me, that 15 amp circuit breaker was about $7 at the store. However, the arc fault protection one was about $61. So if you're going to be replacing several all at once, that could be a pretty hefty bill. The second reason is that some earlier iterations of the arc fault protection breakers were prone to what we call nuisance tripping, which means that even when everything in your house is working correctly, they would go off and they would shut the power off, and it was kind of annoying to have to go to your panel and flip it back on. Today, a lot of these arc fault circuit breakers are a lot more advanced, and they have a little circuit chip in them that can sort of detect different types of arcs, some that are supposed to be there and some that are not. You might still find that the nuisance tripping happens every once in a while, especially if you're using something with a motor. For example, your vacuum cleaner has a motor which could have some controlled arcing, which could set off the breaker. Another reason that you might not jump into changing out all your breakers all at once is that the arc fault protection breakers come in a standard width, and you may have a panel that's already completely full. You may be using several half-size breakers already, so you can't just pull out a half-size breaker and put in this full-size arc fault circuit breaker. And actually, one of the reasons that we upgraded our panel in the first place is so that we'd have some more spaces to do that. Another option, if you don't have space in your panel, is to just install the outlet style arc fault protection. So we're going to go ahead and install this combination arc fault circuit interrupter. You notice it says combination. That just means that it can protect against both parallel and series arcs. Pretty much everything you're going to buy on the shelf is going to do so, and that's great because that's what was required by code. Our breaker should not be confused with a dual function breaker, which has both ground fault as well as arc fault protection. So before working in your circuit panel, it's good to make sure that you really know what you're doing. Consult an electrician if you have any questions. And then of course, if you ever don't feel comfortable, then save it for the professionals. If you don't feel comfortable working in a live panel, you can shut off the main breaker so that your live bars are deactivated. However, don't forget that the terminals will still have electricity going through them. And then of course, I'm going to shut off the breaker that we're going to work with before we get started. This is the breaker that we're going to replace. So I'm just going to follow that black lead all the way back to the source wire, and then find the white wire that it pairs with, and then follow that white wire all the way down. And I found it to be this one right here. So the first thing I'm going to do is, with the breaker in the off position, I'm going to go ahead and disconnect this black wire. So next we're going to disconnect the neutral wire from the neutral bus, and after I disconnect it, I'll need to fish it out and just to give myself enough wire to work with. And then while you're doing this, be careful not to touch any of the hot components. Next, I will just remove the old breaker. And next, we'll just reconnect everything to the AFCI breaker. So you'll see it has the load neutral, so that's what we're going to connect the white wire to. And it has the load power, which is what we're going to connect the black wire to. And of course, it has this strip gauge, so I see that my white wire is just a little bit long. So I'm actually going to trim it just a little bit. So next, just loosen these two screws and then insert the wires. So the last thing to connect is this pigtail. If you have too much, then you can always trim it back. And we're just going to connect it in the same spot that the original neutral came from. So next we just mount the breaker, and always put it in the off position before you do. We just connected the hot conductor and the neutral conductor, while the ground conductor was connected the entire time. So now let's flip it on to see if everything's functioning correctly. And you'll notice that there is a test button, which we can test the system. And then of course, to reset it, we turn it off and then back on again. Now that everything is functioning properly, just go ahead and put that cover back on. So that's everything about arc fault circuit interrupters. I hope this was helpful for you guys. If there's anything else I left out, please leave that information in the comment section down below. And as always, like and subscribe. Thanks, see you later.